Okay, so in this video, I'm going to talk about the difference between KP and KC. So first thing we got to know is what KC is. KC is the concentration of products over the concentration of reactants. So these brackets show us concentration as opposed to something else, because products, it could be many things. It doesn't just have to be concentration. Now our KP shows us the pressure of products over the pressure of the reactants. So these parentheses show us that they're the pressure of the products that are being measured and the pressure of the reactants which are being measured. So the question you want to ask yourself is, can the pressure of the product sometimes equal the pressure of, can the pressure of the product sometimes equal the concentration of the products? And can the reactants concentrations equal the reactants pressures? And the answer is, it depends. So another equation that shows this is Kp equals Kc times RT to the change in moles of gas. So if your change in moles of gas in a reaction equals 0, then your pressures actually are the same as your concentrations. The reason is because anything raised to the 0 power equals 1. So what we get here is this canceling out and equaling 1, and Kp equals Kc. But if we don't have 0 as our change in moles of gas, like we have 1 or we have -1, we have 2, 3, -4, anything, then we're not going to get Kc equals to Kp, because what's going to happen is, instead of getting 1, we're going to get a number here. We're going to get R times T raised to the power of something, right? So what we're going to do is look at these problems over here on this side and try to figure out where the moles of gas are going to be 0 so that we can get a Kp that equals a Kc. So here we go. The first one here, we have 1 mole of gas, right? Because there's an invisible 1 every time you don't see a coefficient. That's just the invisible 1. Here we have a coefficient of 2, but this is a liquid, not a gas, so we can't count it. And here we also have a coefficient of 2, but this is aqueous state, so we don't count it either. We only count the gas moles. So apparently there's 0 moles on this side of gas. So the change in moles is going to be 1, right? Because 1 minus 0 equals 1. So we are going to put in our Kc, and our RT is not going to go away because it's raised to the power of 1 minus 0, also known as 1. So now we know our Kc does not equal our Kp. Let's solve our Kc, because what if the question was not asking for Kp? What if it was asking for Kc? How would you write that? So you'd put concentration of products over concentration of reactants. So let's start with our products. One of our products is O2 gas. The other product is 2H2O. But the thing is, there's a liquid here. And liquids do not count in these. Actually, they do not get included. So we don't pay attention to them. Liquids and solids, we're not going to include them, okay? Technically, they're going to equal 1, and 1 doesn't do anything in a reaction. So just ignore liquids and solids when writing your case. So, but down here we have aqueous, and aqueous does get included. Everything but liquids and solids. So gases, aqueous, they get included. We have H2O2, right? But we don't just have 1. This coefficient here shows that we have 2 moles of it. So You have to account for that by writing a 2 here in the exponent position. And your Kc is basically going to equal this. You're going to find out what the concentration of O2 is. You're going to find out what the concentration of H2O2 is. Make sure you square that because there's a 2. And, divide and you'll find your Kc. Once you find your Kc, you can plug it in here and find Kp as long as you have been given the concentrations of these to find Kc. So let's see if the next one has no change in moles, right? So far we see a solid. We know that that's not a gas, so we have 0 moles on the product side of gas. Now let's go to the side. So aqueous. So we also have 0 moles on this side. So this actually is not even going to solve for Kp because there's no gas, and gas is what gives us partial pressure, and that's the reason we use Kp. We'll only have a Kc for this. So the Kc is going to be products over reactants, concentration of products over reactants. So like I said, liquids and solids, they do not show up. So in place of this AgCl, which would have gone on top if it was any other state, we put a 1 because they just turned into 1. Go to 1. There was also an invisible 1 here when I didn't include the H2O, but I didn't write it. But here you have to write it because can't have like nothing there, So let's do this. Let's put the Ag plus here and the Cl minus. So your answer is going to be whatever the concentrations are for the Ag times the Cl, and you're going to do 1 divided by those. So let's go to the next one. So here we have 2 NO2. So that means we have 2 moles of gas. And here, apparently, we just have 1 mole of gas. So this is going to be similar to the first one where we have 1 minus 0, except it's going to be 2 minus 1. But in the end, it's just a change of 1 mole. So here's my change of 1 mole. Here's my Kc. And to find Kp, I'm going to have to multiply these. Now the Kc is going to be the concentration of NO2, and then it's going to be raised to the power of 2 because there's a coefficient of 2 in front of it. Don't forget those. And then here's a 2, N2O4. Since there's no coefficient in front of it, we don't put anything. There's a 1, but anything raised to the 1 powers itself. So that's your Kc. Once you find it, you can plug it into here and find your Kp when you are given concentration. So let's see if the next one has Kc equal to Kp. So here we have 2 moles of gas. And here's 1 mole of gas because we have an invisible 1, right? And here's another mole of gas. So it looks like this is actually the one. So we're going to have a change in moles of 0 because 2 minus 2, products moles minus reactants moles is going to equal 0. So here's our RT, which I'm going to cancel out in a second. It's Kc, it's Kp. So here our Kc and our Kp equal each other because this disappears. So great. This means that whatever Kc equals, that's our Kp. So let's write our Kc out. Kc equals concentration of NO to the power of 2. The power of 2 because there's 2 moles of it over the concentration of reactants. We only have 1 mole of N2 and 1 mole of O2. Great, that's going to be our Kc and our Kp. So let's do this last one. So we have 2 moles of NH3 and we have 3 moles H2. So I can already tell this is not one of those where Kp equals Kc. Of 1 mole N2. So what we have here is 2 minus 3 plus 1, which is 4. So we're actually going to get a negative exponent, and that's fine. So our Kp is going to equal whatever Kc is times RT raised to the power of -2. This equals -2. So maybe I'll just put -2. So let's solve for our Kc. Our Kc is going to be equal to the concentration of NH3 raised to the power of 2 because there's 2 of them. And then it's going to be over our reactants, which is going to be H2. And in this case, there's 3 moles of H2 gas, so we're going to put 3 here. And then we only have 1 mole of N2, you can see. So here it is. So you just plug in the concentrations which would be given to you, and you can find Kc if you are given all 3 of these concentrations. Now let's say you're not given the concentrations. You could also be possibly, even though it's less likely, be given the pressures and told to solve for Kp. So if you're given the pressures, just go ahead and put the pressures of your products over the pressures of your reactants. Just like I rewrote it, but that's how it goes. But it's just a little less likely. Most likely you'll be given concentrations, and then you'll solve for Kc, and if they want Kp, you'll be given the temperature. And the R, like I said, I might have mentioned it, is 0.0821, I believe. And then the units for it, I'll have to look up, but this is the number. So that's basically it. Let's see if I have a problem for you. So I'm gonna clear this and do a problem. So here's a problem. Actually, I don't have to rewrite it because it's already here. We're gonna use this one. The concentrations for N2 gas are gonna be 2.05. Concentrations for H2 are going to be, let's see, 1.56. And for NH3, it's going to be 1.52. Not sure if this question has been done already in class, but we'll just do it. So let's say the question asks for Kc. So to find Kc, we do concentrations of products over reactants. So our products in this case are going to be here. So let's just replace them. 1.52 raised to the 2 because there's 2 moles of NH3 over basically 1.56, which is going to be our H2. And it's raised to the power of 3 because there's 3 moles. Is our N2. And it's not raised to anything because there's only 1. So cool, this is our Kc. And when you solve for it, you get 0.297. Now let's say we wanted to find Kp. We would use this Kc. And we'd also have to be given a temperature, which the problem is at. So let's say this is at 700 K. So Kp is going to equal the Kc times R times T times to the change in moles. Earlier we said the change in moles was -2, right? So let's put that in there. And then we have our temperature in 700 Kelvin. One thing you have to know, your temperature does have to be in Kelvin because the R is in units Kelvin at somewhere in it. I have to double check. So just make sure it's in Kelvin. And then Kc is going to be our 0.297. And you just solve for Kp. So I haven't solved it. I guess I should just do it. And yeah, you guys should solve along. Um, okay, so something's wrong with my calculator. But I'll put the answer in the description of the video. So sorry, I'm just using my phone right now. My calculator is kind of messed up. So Kp is just going to equal this. Look in the description of the video for the answer to this case. But that is all for Kp and Kp. Thanks, guys.